Hey, what's up guys? Welcome to Deep Tensor channel. Okay, vanishing gradient behavior exists when you have a very deep neural networks, especially for a type of called current neural networks and the other types. But as I stated before, it can be exists in any neural networks type. However, when we have a deep neural networks with much of computations, very deep neural networks, which means much of computations as well as the number of layers are very high, vanishing gradients exist. As a result, vanishing gradient happens when the first one is bad weights initialization. For example, we initialized the weights with very high or very low values. This is the first condition, or the second condition when we have a very deep neural networks. Also, in other research papers, we may have a third reason, which is called the activation functions. So if one of those reasons exists, vanishing gradients will be exists. So let's have our third rule when vanishing gradients exists. Vanishing gradient exists during the training process. When the training process started, specifically when the derivatives calculated. Recall, neural networks process consists of two main processes, the forward propagation and the backward propagation. Specifically in backward propagation, the derivatives are calculated. So if we have a neural networks model, each iteration, the derivatives are calculated and updated. So our target is to find the global or local minimum. So the cost function are optimized. Let's imagine a very big neural networks. We have with number of layers equal L with 100 layer. So recalling from the backpropagation calculation, when we derive the derivatives weights, let's assume for simplicity the weights equal like this: 0.5, 0, 0, and 0.5. Okay. And if we have the y hat or y prediction is equal the WL 0.5, 0, 0, and 0.5 to the power of L minus 1. This is for the overall neural networks model times X. Okay, and this is the input feature. If we say that L are very large, and we have the first value of weight W11, which is equal here 0.5, so the results is 0.5 to the power of 100 minus 1, which is equal 1.5 times 10 to the power negative 30. This will impact the y hat will be very small. If we have the derivatives of weights are very low, this will impact the y hat value are very low, and this will impact the cost function will be very low value. For example, if we have in the first iteration cost function iteration 1 0.5 and the second iteration 0.49999, so the difference between those will be equal 0.000001, something like that. This is impact a very tiny step, and this tiny step makes the training process time takes too long. How we can prevent the problems of vanishing gradient to exist in our deep neural networks? So I can tell you the solutions will be using two criteria. Number one is weight initialization, and the second one is change the activation functions. We can solve the problem of vanishing gradient using weights initialization to be a random initialization. The other solution is change the activation function to use non-linear activation function such as relu or leaky relu and so on. And that's it. In the next video, we will take the exploding gradient with our 4-question WWWH. Leave your comments and let me know if you have any questions, concerns, or want to apply a specific idea or project in machine learning or data analysis. Thanks.